Hello, welcome back to SCI Teach. This is a physics practical on glass prism optics. So we're going to use a rectangular glass prism in this experiment. We are going to use a sample question from 2024 Waec and try and see how to solve questions on optics, rectangular glass block. Alright, remember to subscribe to this channel, like and share the videos to your friends and classmates so that as we are enjoying, they are enjoying also. Alright, let's go. So this is my apparatus. I have my optical pins. We need about 4 of them. I can have extra for eventualities. I have my paper firmly put on the drawing board. So I have a drawing board then. I have a paper firmly put by the thumb tags. And I have my glass prism. I have ruler and my what I will use in measuring my angles all set. Okay. So I've put the paper on the drawing board. I've held them firmly with the thumb tags. I'm going to go ahead to carry out the instructions of the paper. Okay. Now, first of all, I will trace the outline of the rectangular glass block. Remember, glass prism are in 2 forms. We have the triangular block and we have the rectangular block. Now we're using the rectangular block. Maybe some other time we use a triangular block to carry out the practical. Okay, so I'll trace the outline of the block, the rectangular block. Okay, make it visible. The edges may not be sharp, may not be pointed, could bend, but however it is, make sure the outline is correctly traced. Okay, what I mean is if you lift it up like this to label A, B, C, and D, make sure that when you place it back, it sits inside, not on the line. Okay, so I'm to label the ends A, B, C, and D. They are going to be useful as one is going to receive the ray and the other is going to refract it and bring it out as refracted ray. Okay, next is to measure my point of normal, and in this case we are using 4 cm. Okay, 4 cm from A to where I'm going to use as my O that the normal will pass through. Okay. So with my ruler, start from 0 to 4 cm. Alright, and as I reach 4, I'm going to use that as my normal. Alright, so I'm going to draw 90 degree. Alright, right now I can use my ruler and get it, but if you need a protractor to keep there and make sure it's a 90 degree, then that's perfect. But I can simply use my eye and see with a straight line to draw my normal there. Okay, remember, if you keep if you draw a normal, you have to label it. Okay, in this case we are calling it N1. That's our normal 1. So that's a normal that crosses AB. That's where the light wave from the optical pins will be entering into the glass prism. So I call that point where it intersects AB, or crosses AB, 0 or O, sorry. And remember I said the distance from A to O is 4 cm. I don't need to write it there, but I'm just using it for explanation right now. Okay, so now we're going to move to the next thing, which is to draw the angle of incidence ray. Okay, so now the equation might give you different angles to start with, but we are going to start with 65 degrees. Okay, so I will try and make 65 degrees from my protractor here. I'll see the 65 degrees there. Okay, I'll make sure my angle is formed 65 degrees. 65 degree angle is to AB, not to NO. Okay, according to the question. Remember, we're using 2024 question as sample question to use and do this. So my 65 degrees is to line AB, not to line N, not to the normal. Okay, so that's my angle 65 degree are formed to the normal, to the line, to the side AB. All right, now I will label that M. Okay, I label my incident ray M, and that's where I'm going to locate two of my pins, the optical pins. So I mark the point where I'm going to locate the pins. All right, and then I put the pins in. These are the pins, optical pins, which I'm going to see through from the other end of the glass prism to see the amount of refraction. So I fix my first pin. I need two pins so that I'll be sure of the line that comes out the other way. If it's just one pin, I won't know of setting the path of the ray, except I was using a light ray. So I fix my pins P1 and P2, so I have to label them. Okay, P1 and P2. All right, when I do that, I would, okay, everything is set. I would then need to replace the glass prism. Remember what I said when replacing it, make sure that the sides are into the shape, not on the lines. Okay, see, if you're to look at it inside the prism, you'll be seeing wrongly. Look at it from the sides, you see that the lines are out. If it's too out, you have to adjust, okay, to make sure that it is inside. Not that it really matters, but I'm just saying, to avoid parallax error, you make sure everything is where it was when you traced it. Okay, because the refracted ray is going to come out from just one side of it, and doesn't really matter how far away that is from the trace. Okay, now if I go down to look at the pins from the side, the opposite side, the other side, which is what we are looking at right now, you will see the pins are coming out of here. We are seeing it through here at another angle. Okay, look at what we are seeing. See where the original pins are. See where our pins from the side of the rectangular block is showing. Okay, I think I have to keep this to be straight so that we don't see those pins as double. Okay, we see it as one straight line. Okay, see the original here, you can already see, look at how clear it is, the refracted one. See what is showing, this down the side here, not top, the side. Okay, so I'm trying to, let's keep it straight so that we'll see those pins are straight. Okay, you see the top is as straight, not two different pins, we see it in one line. So you see now the pins coming out from the side of this other side is now looking straight. Okay, remember you have to align it accurately because we are looking for the angle, the amount of refraction we have. All right, so I think it's straight now. Okay, so clearly you see where you are seeing your refracted pins, you're going to place the other two pins to follow where you see this. So I'm placing the third pin here to follow to align with the pins I'm seeing through the side of the rectangular glass block. I'll place that one firmly, because that's my P3. Remember the first two orders before I replace this thing was the P1 and the P2. So this is my P3, trying to make stand firm. Okay, I think it's firm now. All right, so make sure it aligns with what you are seeing through the glass prism. So I've put my P3. I'm going to add the P4 to it. So you see clearly when you're doing yours, make sure your eyesight is okay before you attempt this question, so that you'll be able to see accurately. So you can see P4 is slightly there. Okay, you must make sure it is what you see through the glass, not just you want to follow the line. See it through the glass. So you have to squat if you have to, or bend to see through the side directly, not from the top, not what you assume that it is. So you can see I've aligned my P3 and P4 according to what I see through the side of the glass. Okay, so when you look at it from the top now, you see that there is a little deflection, a little diffraction, a little refraction from where it was. If we were to go straight, it would have passed in front of this P3 and P4, but it won't go straight, because when light passes from one medium into another medium, the speed of the light changes, and this changing the speed of light is what is shown by a refracted ray. The ray bends, so the object that was seen outside the medium, inside the medium, would be seen in a refracted angle. Okay, so I've labeled P3 and P4. I'm going to join P3 and P4 to side CD with my ruler. Okay, so I'm making sure that you don't draw a line that passes by the point. It must pass through the points. Okay, so you can already see the amount of refraction we have. Okay, the amount of refraction will increase as the normal closes, as the angle at AB closes. So the angles will be increasing. So the question may ask you to then repeat that for other for different angles you'll be given, and then you are asked to record. Okay, so when you are asked to record, you make sure that you record accurately, the correct dimension, the correct decimal places, and everything you are asked to record. All right. Okay, so I connect my O to the meeting point of P3 and P4 to CD, and to find my angle of refraction. Okay, so you see the amount of refraction that was happened here. Okay, I'm going to do that and then measure or try and put another normal, my normal 2. So I'm going to call that N2, but this time at the intersection of P3 and P4 on CD. So that's my N2, my second normal. Okay, so you see now how beautiful the refracted ray looks. Okay, that's going to close up, or that's going to bend the more as the P1 and P2, the angle at the 65 degrees we use there changes to 55 or 45 as the case may be. Then this bend, this refracted ray will increase and bend the more. Okay, so when we do that, the next thing would be to carry out our recordings. Okay, now the question then asks a little creative thing for us to draw a circle at O, and we are given dimension. Okay, so that's what I'm about to do now. Of course, you're going to use a compass if you're going to draw an accurate circle. Okay, so I fix my pencil in the compass and measure the dimension we are given. We are told, remember we're using 2024 question as sample, so we're told 3 cm. I measure my 3 cm or 3 cm. Okay, that's 3 cm. Right, so that's going to be the radius of my circle. This 3 cm will be the radius of my circle. Okay, so I'll measure that and then transfer it to my work. O as the center, okay, and then I draw my circle, and that circle will touch and cross all the crossables. Alright, well, what I'll be getting from this circle is part of what I need for my table, my values, which I'll use in plotting my graph. Okay, so what do I need? I'll draw a line, the intersection between the incident ray and the normal, okay, a 90 degree to form 90 degree at n at normal 1. Okay, so make sure it's 90 degree. If not, you can use a protractor, but make sure it is 90 degree line, so a straight line parallel to AB. Okay, I do the same thing for the refracted ray area. So you see it's 90 degree, right? Make sure it's 90 degree when you are working on yours. I'm able to be straight because I've done this over and over again. You may need to use a protractor to ensure it's 90 degrees. So I do the same thing for the refracted ray side. Okay, so that's it, it's forming. I'm going to get my values from there. Remember that our incident angle was 65 degree. I didn't write it there, so I have to put it there because we need it to differentiate the first setup, the first diagram from the second and the third and subsequent diagrams. So our level is 65 degrees, and then the line I drew at the intersection of P1 and P2 is going to be called XY. So I put in that my theta is 65 degree, and I'm going to carry out another one for 55 degree, carry out another one for 45 degree, carry out another one for 35 degree, and also for 25 degrees. So that's 1, 2, 3, 4, and the one we are doing right now, which is the fifth one. Okay, so that's how 2024 asked. That's what the questions were to repeat with these different dimensions. Okay, so I label my line XY, which is between incident ray and N1, and label QR as between N1 and the refracted ray. So you see this point is my refracted ray, where the ray incident ray comes out or comes into the glass prism which was refracted. I put all those measurements because it's going to be used, and I record and see that my refracted ray is 20 degree. The angle of refraction is 20 degrees, so my R is 20 degree. Now I need to record all this because I'm going to tabulate them. Okay, so I record R is 20 degree. For this first diagram, when we're dealing with 65 degree angle of incidence, okay, I'll record my XY and also record my QR. My XY is 1 point. Okay, my XY is 1.3 cm. Okay, so I also do the same thing for QR. They are going to be useful. If you see 2024 questions, you will see how useful they are. So your own sets, you may be asked to measure some other thing. You may not be asked to put a circle. We're just using this as a case study. So make sure you measure everything accurately. Stand to measure, not sit, so you will see everything clearly. So my QR is 1.1 cm, and my XY is 1.3 cm. And then we may be given a formula, like in the case of 2024, formula for Y, which Y is XY plus QR. So that's to say I have to add up the 1.3 I had with the 1.1. Okay, that's for Y. So there will be a place in the table called Y, and that's what you will input. Okay, so I label my I put my 1.3. Remember that in physics you need all the decimal places as much as possible, so I wrote before 1.3 cm. It's not supposed to be like that, at least 2 decimal places. So I replace it with 1.30 cm. Okay, make sure you don't make mistakes like this. Okay, and the other one is 1.10. So I add them up, 1.30 plus 1.10 and I have 2.40 cm for my y. That's only for 65 degree angle. Okay, we're going to be asked to repeat all those and then form a table which are going to use to plot a graph of whatever you're going to ask against whatever you're going to ask. When you're plotting, remember to use a reasonable scale. Okay, and then remember your y-axis is the vertical and the x-axis is the horizontal. Y-axis could be from the end depending on your values. The x-axis could be, or the y-axis could be at the center if you have a lot of negative values in your reading. So the graph should look like this. Graph should look like that. Okay, so that's what you will be facing, something close to that in your physics practical question 2. When you see that, don't be afraid. Just be able to go through it and follow the instruction and do it accurately, and plot your graph to the right scale and make sure everything is done with the correct dimensions and you did everything and cross-checked and it was right. If you have a bad eyesight, please, you may need to avoid question 2 glass prism, especially when it's glass prism for the optics, because you may be having wrong readings which may affect your grade in physics Waec. So you may want to do question 1, which is moment, and question 3, which is electricity, and not question 2 if you have an eye bad sight. But if your eye is okay and you can measure things accurately, question 2 is very easy. It's very easy. 3 is easy also, electricity, but you have 3 questions to choose 2 of them to answer. Make sure you answer the ones that reflect the best of your performance so that you score very high marks in your exams. And remember that success does not come from cramming. Success comes from understanding the concept and knowing the application, so that when you are asked questions related to glass prism, you will still be able to answer. Okay, because you understand optics, you understand light waves, and you are able to deal with whatever comes there, whether lens or prism or whatever, optical illusions or whatever happens. Understand the concept. So read, understand, and then practice. Don't just let your exam not be the first time you answer that question. You're going to get it wrongly. So if you've not done this before, don't attempt it in your exams, because you're going to do it wrongly. Okay, you still have time to use this and practice. You can use that 2024 question and see how I've done it now, and practice with you to get yourself prepared for question 2, because this is what you're going to see in your exams. Not the same question, but it is going to be glass prism, and you're going to do more or less the same thing I've done here. Okay, so remember to subscribe to this channel, like and share the videos to your friends, classmates, your loved ones who are writing exams or need knowledge of glass prisms, and I'm sure they will excel in their examinations or in their endeavors and academics, as you will make your good grades in this coming examination. Thank you for watching. God bless you.